All right, so we are going to find actual locations of extrema for functions. So locations of maxes and mins through the use of calculus and tangent slope generators. So we're going to first start by finding the critical points, or possible locations of our max and mins. We're going to take our derivative, set it equal to 0 or c when it's undefined. We will not have to worry about this undefined part if there is no denominator for our derivative. We will solve. And then comes the new step of doing an analysis of the signs of f prime. So at negative 5, 6, I had a 0. Typically, we go back into our factored form, but there's no really factored form, so we'll go back into the negative 6x plus 5, and I'll pick a test point, knowing that since I have a 0, 0 separates negatives from positives. To the right of this will all be positive. To the left of this will all be positive or negative. So as long as I just pick one test point, say at like 0, if I plug in 0, I get negative 5. I know that all of the signs of f prime are going to be negative, which means behavior of f, which I'll put down here, f is going down. It's decreasing from left to right when the derivative is negative. I'm assuming it's going to be positive here, but let's check. Let's plug in a value like negative 2. Negative 2 times negative 6 is positive 12 minus 5. That's going to be a positive value, which means f is going up, which means x equals negative 5, 6 is a max. All right, let's look at our next function. Cubic function. Take the derivative. 3 times 1/3 is just 1. X squared plus 6x plus 8. We'll set that equal to 0 or c when it's undefined. I don't have to worry about it because there's no denominator. X plus 4, x plus 2. X is equal to negative 4, negative 2. Those are possible locations of maxes and mins. I will go ahead and do an analysis of the signs of f prime, making sure I list these in order. Negative 4 is to the left of negative 2. That's important. And pick some test points. Say 0. Now, plugging our test point into x plus 4 times x plus 2 is going to be easier than plugging it into x squared plus 6x plus 8, because when I plug in 0, I see it's 4 times 2. That's a positive times a positive. I don't care about the numerical value. Just care about the sign. Negative 3 plus 4 is a positive. Negative 3 plus 2 is a negative. So that's why I know this is a negative. These are zeros. Zeros separate positive from negative values. Negative 5, I have a negative times a negative. So that's a positive. So that means f is going to be going up, then down, then up, which means x equals negative 4 would be the location of a max. X equals negative 2 would be the location of a min. Next one. Tangent slope generators. So you want to generate a 0, factor out an x. Since I factor out an x, 0 and 6 are going to be my critical points. Analysis of the signs of f prime, 0 and 6. Use a test point. I like to start to the right. I think you've noticed that I always start to the right of things with like the most positive value or like the largest value, and then work my way to the left. I just think it's easier to do. Plug in something like 7. 7 times, that would be negative 1. So that's a positive times a negative. So that is a negative. Something like 2. Positive, positive. Something like a negative 1. Negative, positive. Okay, so F is going down, then up, then down. I know this is going to be the location of a min. This is the location of a max. Check this one out. 2x squared minus x cubed. No denominator, don't have to worry about the undefined part. I'll factor out x squared now. So I still get 0 because I factored out an x and 2. But now, let's be careful. This is going to be very, very important in this unit, and especially for the next lesson. We will not have a sign change at 0. I know that for a fact. Because of this x squared, like this multiplicity, this being a 2, just means that we'll kind of like bounce off of 0. Also, just like no matter what, if I plug in a negative or a positive and square it, it'll become a positive. So I just know that going into this, but I'm going to still do the analysis of what would be going on. So starting at 3, I'd have a positive, and then 2 minus 3 is a negative. So positive times a negative, that's a negative. At 1, positive, positive. So I guarantee you at negative 1 will be a positive. Let's see. Negative 1 squared, positive 1. 2 minus negative 1, positive 3. Positive times a positive, well, positive. Okay? So that means F is going up. It's flattening out. It's going up. And then it's going down. So you can think about like a little bit of x cubed there, where this is not a max nor a min. So it's good to make sure you understand that is neither a max nor a min. And x equals 2 is a max. This is going to be a similar situation because I'll have an x squared. 20x squared, x minus 3. 0 and 3, sign analysis. Positive, positive for something like 4. For something like 2, positive, negative. For something like negative 1, positive, negative. Make sure you practice this sign generation, because if it's a struggle for students, then it's something that needs to be practiced. Okay, so in this situation, F comes down, flattens out, goes down, and then comes back up. So x equals 0 is neither a max nor a min. X equals 3 is a min. All right. Got x to the 4th. X cubed minus 6x squared plus 5x. I'll factor out an x. X squared minus 6 plus x plus 5. Set this equal to 0. I'm going to factor this. X minus 5, x minus 1. 3 locations of possible maxes and mins, 0, 1, and 5. Let's do our sign analysis. Starting with a test point like 6, positive, positive, positive. Something like 2, positive, negative, positive. Something like a half, positive, negative, negative. Positive. Something like negative 1, negative, negative, negative. Okay, so that means F is going to be going down, then up, then down, then up, which means I will have a min at 0, a max at 1, a min at 5. All right, good stuff. So what does my function look like? Down, up, x to the 4th. Shouldn't make sense. But we know the exact locations of these maxes and mins, which is cool. Sine x plus 1/2 x from 0 to 2 pi. Well, same process. Get cos x plus 1/2. Set that equal to 0, or see when it's undefined. Don't have to worry about that. To solve this, I'm going to have cos x equals to negative 1/2. Unit circle. One is the horizontal negative 1/2. It's going to be at 2 pi over 3 and 4 pi over 3. We're going to stop there. Sine analysis. Here we go. What are we going to do here? Well, what's important, and this is going to be used, is that like we have an interval from 0 to 2 pi. Now, I actually could use 0 as a test point and 2 pi as my test point. You don't have to, but you can, because like the next 0 wouldn't be until I went to negative, sorry, this is wrong. This should be, no, this is right. Should be negative 2 pi over 3. So like my next 0 would be negative 2 pi over 3. So I could use 0. But like if you're not comfortable using 0, you could use something like pi over 6 or pi over 3. Or even pi over 2. I might as well use pi over 2. Pi over 2 is between 0 and 2 pi. Cosine of pi over 2 plus 1/2. Cosine of pi over 2 is 0 plus 1/2 positive. This is what we're thinking of. Between 2 pi over 3 and 4 pi over 3, pi, a good one to use. Cosine of pi plus 1/2. The cosine of pi is negative 1 plus 1/2 would be a negative value. Between 4 pi over 3 and 2 pi, 3 pi over 2, good one to use. We could also use 2 pi as well, but it's okay. Cosine of 3 pi over 2 is 0 plus 1/2, positive. So F is going to be going up, then down, then up. So x equals 2 pi over 3 is a max. X equals 4 pi over 3 is a min. Okay? If we did not get this one, did not understand it, you should try this one by yourself. Because we need to be comfortable doing this. Making sure we keep track of signs for derivatives. I would add 1, but then divide by negative 1. I get sine x is equal to negative 1. What is sine equal to negative 1 between 0 and 2 pi? 3 pi over 2. So I only have one possible max or min between 0 and 2 pi. Now I got a lot of possibilities here. Pi over 2, whatever I want for a test point. I would plug it back into this, negative sine pi minus 1. Sine of pi is 0, 0 minus 1, that's a negative. 3 pi over 2 and 2 pi, I would probably pick I don't know, 11 pi over 6 or something like that. I feel like I made a mistake here, but let's see. Okay, negative sine of 11 pi over 6 minus 1. Sine of 11 pi over 6 is negative a half. So I have minus negative a half minus 1. That also is negative. What did I do wrong here? I feel like I'm taking crazy pills right now. Hold on, pausing. We'll figure this out. All right, I figured it out. So, yeah, this is a 0. If I plug in something like 11 pi over 6, just like I thought, negative sign of 11 pi over 6 minus 1 is also going to be negative. And it's like, well, I guess, like, I don't have a max or a min. And I went ahead and graphed and saw that, yeah, that's actually the case. We don't have a max or a min at 3 pi over 2. It's a pretty cool looking function, this cos x minus x. I'll show you. Make sure your calculator's in radian mode. So here it is, from 0 to 2 pi. We can see the function goes down, it flattens out, and then it goes down. Guess where it flattens out? At 3 pi over 2. So our analysis was correct. I just thought that this would have a max or min. But turns out no maxes or mins for this. But we do have a critical point. All right, great. Moving on. Chain rule. O's and I's. Outside. Inside. Derivatives. Let's go. 3 x squared minus 1 squared times 2x. 6x x squared minus 1 squared. Careful. You could factor x squared minus 1, x plus 1, x minus 1. That is being squared, though. So we have interesting points here. We're going to have 0, negative 1, and positive 1. Make sure you list them in order. Now, the only thing that's going to change signs is the 6x. Because this x plus 1 times x minus 1 is being squared, I know it's always going to be positive. So like times a positive, times a positive, times a positive, times a positive. 6x, well, to the right of 1, positive. To the right of 0, positive. To the left of 0, negative. To the left of negative 1, negative. So we are going to go down, flatten out, go down, flatten out, go up, flatten out, go up, where x equals 0 is our only min. X equals negative 1 is neither a min nor a max. And x equals 1 is neither a min nor a max. This is going to be really cool if we look at graphically. X squared minus 1 quantity cubed. Okay, we start at like negative 3. We decrease, flatten out at negative 1, decrease, min at 0, increase, flatten out at 1, increase after that. Okay, we figured that out just by doing an analysis of derivatives. Look at this guy. All right, now we have to be careful. We will have a denominator. That's a half. So don't forget about this part. One over 2 root x minus 1/3. My numbers are all over the place. Equals 0 or undefined. Immediately, I'm thinking x equals 0. We will have a 0 in my denominator. Okay, so this is a critical point. Let's not forget about that. Now let's solve the other piece, the 1 over 2 root x minus 1/3 equals 0. So I'll add a third. I'll flip both sides. So I got 1 over 2 root x equals a third. Flip 2 root x equals 3. Root x is equal to 3/2. X is equal to 9/4. And only positive 9/4, not negative 9/4. It's not x squared. So 0 and 9/4. Now this is what's interesting here. This function, I can only plug in x is bigger than or equal to 0 because we don't want to take roots of negatives. So it's actually 0 is a starting point. So I don't need to worry about that. I just need to start at 0, plug in a value between 0 and 9/4, like 1. So what would I plug in? I would plug it into this, my derivative. Now it's not factored, but it's going to work out easily. It's going to be 1 over 2, if I used a test point of 1, minus 1 over 3. 1/2 minus a third, I know is a positive. If I plug something bigger than 9/4, I know I'm going to plug it into a square root, so might as well use something that you can easily square root, like 4. Because I have 1 over 2 times 2, which is 1/4 minus a third. A fourth minus a third is negative. So I know that f, starting at 0, is going to go up, but then after 9/4, it's going to go down. So x equals 9/4 is going to be a max. For these like more interesting ones, I like to graph them just to see and confirm I know what I'm doing. So square root of x minus 1/3 x. We are going up until 9/4. Watch, trace, 9/4. Boom, max. If I click to the right, this y value should go down. Went down. We're decreasing from there. So we're on top of it. X to 2/3 plus 2x minus 3. Let's see. Don't neglect this situation. Here, I know, again, if I have a 0 in a denominator, x equals 0 is a critical point. I'll solve the other situation. Subtract 2. You can flip, do whatever you want to solve this. Multiply by 2. Divide by 3. To solve, cube both sides. I get x equals negative 1/3 cubed would be negative 1/27. All right, so 0 and negative 1/27. Now this is a tricky one. I could plug in something bigger than 0 into this. Positive 1. 2/3 plus 2, positive. That's easy. But when I plug something like in between 0 and negative 1/27, what should I do? Well, you're going to plug it into here. So pick something that you can cube root. So like, 64, which is 4 cubed. If I plugged in negative 1/64, let's see what would happen. I'd get 2 over 3 times negative 1/64 cube rooted, which is negative 1/4, plus 2. That is 2 over negative 3/4 plus 2. That is negative 8/3 plus 2. Negative 8/3 is bigger than 2, so this ends up being negative. That is tricky. To do if you've never done it before. Anything else like, I don't know, negative 8, that's an easy one to do. Negative 8 cube root is negative 2. 2 over 3 times negative 2 is negative 6. It'll be like a fraction plus 2. That is definitely going to be positive. So it looks like I have a max at negative 1/27 in minute 0. Let's see. X to the 2/3 plus 2x minus 3. I'm going to assume that this isn't going to work out well, and I need to put parentheses. Oh man, you can't see it, but watch if I zoom in. So right here, if I zoom in even more, it's kind of crazy, but we're on top of it. See this little hump right there? That's a max. See this sharp point? That's a min. Where is that max going to be? Negative 1/27. That is a max. If I click to the left, it's going to be a smaller y value. If I click to the right, it's going to be a smaller y value, just barely smaller. And then at 0, I have a min, and because I increase after that. So like we're all over this. We just kind of understood what that function looks like through its analysis of derivatives. Tricky though, tricky. This one's tricky as well. Here we go. I get 1/3 x to the negative 2/3 minus 1/27, 0 undefined. X equals 0, we'll put a 0 in my denominator. So don't neglect x equals 0. Solve. Add 1/27. Flip both sides. Divide by 3. Take both sides to the 3/2 power. 9 to the 3/2 is 9 square rooted cubed. Square root of 9 is 3. 3 cubed is 27. Cool. So, in my analysis, I'm going to have 0 and 27. This is my derivative. plugging in values that would work in x to the 2/3 is important. An easy value to plug into any x to a power is 1. So that's my first test point, 1. Because I would end up just having 1/3 minus 1/27. 1/3 is bigger than 1/27. Positives win. Now, I'd have to cube root then square. The next number that's easy to cube root and then square is 64. Because cube root of 64 is 4. 4 squared is 16. So I have 1 over 3 times 16 minus 1 over 27. 3 times 16 is going to be a larger value. And if I subtract 127, I mean like in terms of the number in the denominator. So this would be a smaller fraction, minus 1/27. That's going to be a negative. If I pop over to the left of 0, I'd probably plug in -1. It would be -1/3. Actually, it would not be -1/3. And I neglected something. Oh my gosh, go back. Because this is x to the 2/3 and I have this even power in the numerator, I need a plus or minus there. It's the same thing as like square rooting x squareds. We need not only 0, but positive 27 and negative 27. Yikes. Now, the great thing is, though, like, x to the 2/3 is always positive. Okay, because I'm going to be squaring and cube rooting. 1 and -1, easy to work with. 1 to the 2/3, 1. -1 to the 2/3, also 1. So 1/3 minus 1/27, that's going to be positive. I'll have a positive here, I'll have a positive here. Now, again, x to the 2/3 is always going to be greater than 0. Going back, plugging in something like 64 or -64 will give me the same value. It'll give me 16. 16 times 3, 48. 1/48 minus 1/27 is going to be negative. This will be the same thing, a negative. Putting all of that analysis into play, we will discover that f is going to be going down, then up, then down. X equals -27 is going to be a min. X equals 0, neither. X equals 27, max. Oops. X to the 1/3. Minus 1/27 x. I'm going to adjust my window from -30 to 30. If I plugged in -27, I'd have a min. If I go to the left, it's going to be a bigger y value. Yep. If I go to the right, bigger y value. -2 is my minimum value. If I go to 0, neither. We have a vertical tangent, neither a max nor a min. If I go to 27, largest y value of 2. If I go to the right, it'll be smaller. If I go to the left, it'd be smaller. Okay, so we did it. Okay. Given f prime is this, is f increasing or decreasing at x equals 1? So it's very important to see we are given f prime. Since we are given f prime, I just need to figure out the sign of f prime. F is increasing if f prime is positive. F is decreasing if f prime is negative. All I need to do is figure out, is f prime of 1 positive or negative? I don't have to set this equal to 0. I don't have to do anything crazy. This is 1 times -2 to the 4th, which is a positive. times negative 1. That's negative. I don't care what the value is. Since f prime of 1 is negative, f is decreasing at x equals 1. Okay? So make sure you understand what you're given in the next question. What am I given? I'm given f prime. Since I'm given f prime, I kind of already have the factored form. I can see when x is 0, 2, and negative 2, I have possible maxes or mins. I will go straight to my analysis. Plugging in test points like 3, positive, positive. This will always be positive, so that's important. Something like 1, positive, positive, positive again. Negative 1, negative, positive, negative 1 plus 2 is a positive, cubed positive. It's a negative. And then negative 3, negative, middle is always positive. Negative 1 cubed, negative. That's a positive. So f is going up, down, up, up. X equals negative 2 is a max. X equals 0 is a min. X equals 2 is neither. What tells us if something is increasing or decreasing? The sign of its derivative. If f prime is this, when is f prime decreasing? This is very important. F prime decreases when f prime's derivative is f double prime is negative. I'll put that. So when is f prime decreasing? Take its derivative. See when its derivative is negative. How do you figure out when something's negative? First, find the zeros or see when it's undefined. Factor to find the zeros. Do an analysis of f double prime. Now watch what happens. Plugging in test points around negative 3 and 1, positives, plug in 0, positive, positive, negative, negative, plugging in negative 4, positive, negative, negative, positive. F prime is increasing, then decreasing, then increasing. F prime is decreasing on the interval from negative 3 to 1 because f double prime is negative. Okay? This is just getting you to understand that sometimes we won't just want f prime. Sometimes we want to figure out if f prime is decreasing. We'll talk more about that next class. If we're given f, when is f prime decreasing? Again, f prime is decreasing when its derivative is negative. That's when f double prime is negative. I'm given f. I don't want to take f prime and set it equal to 0. I'm going to go a step further and look at the second derivative and set that equal to 0 because I want when f prime's derivative is negative. How do you figure out when something's negative? First, set it equal to 0. Once you find the zeros, you can do analysis of the signs around the zeros. If I plug in something like 0, it's positive. Something like negative 2, it'll be negative. That means f prime is decreasing, then increasing. So f prime is decreasing for x is less than negative 1. Why? Because f double prime is negative. All right, to the fun questions. Given the graph of f prime, when does f have relative maxes or mins? What type? It's important to realize 0 is not a max. This is f prime. So this is not f. Remember, this is like the derivative. It's the tangent slope generator for f. What we will want to do is just go straight to a sign analysis and think, okay, positive f prime values, negative f prime values. F prime is negative until this -3. It is positive all the way till 2, and then it's negative after that. That means f is going down, then going up, then going down. I can kind of sketch f on top of it. I'm not exactly sure where things are going to be located, but I know I'm going to be going down, going up, going down, something like that. So, knowing that, I know for f, x equals -3 is a min. X equals 2 is going to be a max. When is f increasing? F is increasing when f prime is positive. F prime is positive from -3 to 2. Maxes and mins, what type? When is f decreasing? Well, go straight to your analysis. You can do a better job here. F prime is negative until -2. It's positive until 0. It's negative until 2, and it's positive after that. That means f is going down, then up, then down, then up. So x equals -2 would be the location of a min. X equals 0, the location of a max. X equals 2, the location of a min. When is f decreasing? F is decreasing when f prime is negative. F prime is negative when x is less than -2, and when x is between 0 and 2. Or we can say from -infinity to -2, and then from 0 to 2. All right, when does f have relative maxima? Please be careful when you're reading questions. Sometimes we'll throw in a maxima or a minima rather than extrema. Maxima means maxes. So when do I have maxes? Well, let's do an analysis. I have positives until -2 when I have a 0. But then I have positives until 1, and I have negatives until 3. Positives after 3. F is going to be going up, flattening out, going up, going down, going up. The only time where I have a max where I go up and down is at 1. How many critical points do I have? Remember, critical points are when we have a 0 for a derivative or an undefined derivative. So right here, and right here, all 3 are critical points. But -2 would not be considered an extrema. So I have 3 critical points. I only have 2 extrema. When is f decreasing? F is decreasing when f prime is negative. F prime is negative from 1 to 3. How many critical points do we have? Remember, when f prime is 0 or undefined, that's a critical point. I have, and if you did a sign analysis, you would be able to see f prime's got positive values until -1, negative values until 1. Now at -1, we have a 0 f prime value. At 1, we have an undefined value. We have an open circle. But we jump from negative f prime values to positive f prime values after 1, from 1 to 2. So I go from negatives to positives, and then at 2 I have another 0, and I go back to being positive. I have 1, 2, 3 critical points. -1, 1, and 2. Now where do I have mins. Min occurs when f prime goes from negative to positive, when f goes from decreasing to increasing. X equals 1 is a min. F prime goes from negative to positive. Even though this is an undefined situation, we remember that we could have on f, and if we have a sharp point, this is still a location of a min. That's probably what's going on the graph of f, given this is its f prime. It goes sharply from a negative tangent slope to a positive tangent slope. This is the location of a min. So don't neglect sharp points or holes. Don't let it freak you out. Okay, where does f have relative extrema? Turns out f does not have relative extrema. F is going to be positive, 0 at 0, and then positive. So there are none. But we do have a critical point. X equals 0 is a critical point. It looks like, sorry, F would be going up, flattening out, and then going up in a certain way. Last one. A bunch of undefined points. I didn't even label them. I don't know. Let's put some values here. At -2, we go from negative values to positive values. At -1, we go from positive values to negative values very quickly. At 0, negatives to positives. At 1, positives to negatives. At 2, negatives to positives. This is crazy. So F goes down, then up, then down, then up, then down, then up. Here we have zeros, 0, 0, 0. And here we have undefined values. What does that mean? We probably have a situation where we're going down, then up, and then sharp point, down, then up, sharp point, down and up. So we'll have like mins at -2, 0, and 2, which are nice flat leveled out mins, but then sharp point maxes at -1 and 1. Pretty cool. So -2 is a min. It'll be like that, as well as 0 and 2. And -1 and 1 will be maxes, and they'll be like sharp point maxes. All right, there's a lot of stuff there. It's a very, very important lesson. I hope we took our time doing this homework.